All right, I want to do a quick review of how to identify a linear function, looking at all multiple representations, graph, table, equation, or context. So very quickly, let's define a linear function. A linear function represents a situation which has a constant growth or constant rate of change. So one at a time, let's start with graph. And what we're looking at here is if we're going to have a constant growth, another way to think of that is that this is a constant slope. And the way we find slope on a graph is change in y over change in x, also rise over run. And the strategy here is to draw slope triangles. So what I do is I pick a couple grid points and I draw myself a nice slope triangle, and I check my change in y and my change in x. What I discover is that that's 4 and that's 5. So right here um, on the graph, I have a slope of 4/5. Remember m, the letter we use for slope, when we're talking about equations, and we'll talk about that later. So let's draw another slope triangle. Well, let's draw this one right here. And what I discover here is that I've got 8 and I've got 10. And so the slope here is 8 over 10. But of course, that reduces to 4 over 5. And what I notice now is that, in fact, this is linear, because it has a constant growth of 4 over 5. All right, so let's talk about equations. Well, equations somewhat straightforward because, for one thing, sorry, jumping back and forth in colors here. For one thing, I could just look and see, well, if I see y equals mx plus b, that's the y-intercept form of my linear equation. But there are other versions of this equation that we need to know about. Let's very quickly talk about b and m. B is the starting value, m is the rate of change, the growth rate, the slope. How do I remember that if I'm not sure? Well, remember that if I'm looking at a graph, that point right there has an x value of 0. And so if I make x equals 0, then I get y equals m times 0 plus b. M times 0, of course, is 0. I get y equals b. So that's the easy way to remember that. But let's talk about some other ways that you might see this equation. You might see this in standard form, and standard form is ax plus by equals c. You may see it in solved for x, which would look like, going back to y equals mx plus b, we would subtract the b and divide by m. You might also see this as 1 over m times y minus b over m if you were to separate out the fractions there. The key on this is that it is linear if x and y don't have powers or other operations on them. So when you're looking at this, you see y squared, it's not linear. Square root of x, not linear. But if you have a x's, 2x, 3x, 4x, and you have 5y's, 6y's, a half a y, those are all linear because you just have an x and a y with no other operations acting on them. So that's really what you're looking for, is do you see just an x and a y with nothing weird going on there? Okay, let's move on to table. On table, we're going to go back to the idea of the slope, the growth rate. We're going to actually calculate the growth rate. And we know that if this is a table of a linear function, that growth rate must be constant. So let's just pick 2 points in the table. We'll go from here to here. Change in y over change in x. Well, 5 minus 2 is 3. 1 minus 0 is 1. I have a growth rate of 3 over 1. Let's pick another point. Change in y over change in x is 11 minus 8, which is 3, over 3 minus 2, which is 1. I've got a growth rate of 3 over 2. Theoretically, I should do all the points just to make sure, but at some point, sometimes it's reasonable to say, oh, look, I've checked 3 of these and they're all linear, and I'm going to work on the assumption that, in fact, this is a linear function because it has a constant growth rate. Now, let's look at the second one, and I'll sort of spoiler alert, I'm changing to red because this is not linear, but let's take a look. Change in y over change in x, 6 minus 3 over 1 minus 0 is 3 over 1. You can't tell, however, by just looking at 1 point, because if you just pick 2 points on a graph, you can always draw a line between them. I need to check some more. Change in y over change in x is 48 minus 24 over 4 minus 3, which is 24 over 1. Notice that these are not equal, and therefore this is nonlinear. And just to remind ourselves, we'll go back up here and we'll write linear next to this one. All right, trying to get through this as quickly as possible so you don't have to sit and watch a big, long video. Situation here's what we're doing is we're looking for keywords that mean constant growth. So what kinds of words are we looking for? Well, one kind of word we might be looking for would be adding. I'm adding 500 books each year. That's a constant. Every single year, you get 500 more books. Boom, constant growth. My growth rate is 500. A gym's customer must pay $50 for a membership plus $3 each time. Hey, that's constant growth. Every time you go into the gym, you add $3 to what you're paying. A bank account starts with $10. Every month, the amount of money in the account is tripled. That is definitely not constant. Now, if you're not really sure, if you're stuck on that one, you're thinking, wow, tripled, let's think about that one. Well, make yourself a quick table of values. So what does the table of values look like? 10, 30, 90. Notice that this goes up by 20 the first month, this goes up by 60 the second month, and so on and so on. Not constant. So the first two are linear, the last one isn't. And as a quick aside, we might also notice that there's a starting point and there's a starting point. This is also a starting point, but since it's not linear, we're not going to work, or excuse me, we're not going to worry about y equals mx plus b. This is some kind of different function. Okay, takeaways very quickly. What do you need to take away? First off, on a graph, we're looking for a constant, really? No? Constant growth. And the key is slope triangles. Change in y over change in x. On a table, looking for constant growth. And we're also going to use change in y over change in x for pairs of points. In the equation, we're looking for x and y without powers or odd operations. We don't want to the power of x. We don't want x squared. We don't want square root of y. We just want x's and y's. We can have more than one of them, 2x, 3y, but no powers or odd operations. And in a context, we're looking for keywords. Ads each time. Plus anything that tells us constant growth. And this is the tricky one, but if you get stuck, turn that into a table. Make a table of a few values and see what you get. All right, thanks for watching, and we'll jump out here.